What up? It's your man Jimmy Chan over here. All right, we're going to talk about systems of non-linear inequalities. But before we do that, we're going to talk about what are inequalities, or just remind you what inequalities are, right? So, some of the things that we used to talk about is that we might have a less than or equal to, or a greater than or equal to sign, right? That means we would include the points because of that equal sign. So in that case, we would use a closed circle. And we also, with that being said, we would use these square brackets as well, right? Because we included, right? So we got to remember that. And then with the less than sign and the greater than sign, because it doesn't include that point, we usually use an open circle. And with open circles, since we can't touch that point or include that point, we use parentheses when we are doing intervals and stuff like that. All right, so those are all kind of interconnected. But more importantly, that open circle and the closed circle is the most important part. If I had a closed circle, okay, and that closed circle, if I connect a bunch of them together, what would I have? I would have a solid line. Now put a bunch of open circles together, then I'm going to have a dotted line. Okay, so that is the biggest part. So let's do a really quick example. Let's say that I had the graph x is less than or equal to 5. Okay, so I am going to deal with this as if, well, not as if, but I'm going to look at the inequality. I'm going to allow that inequality to tell me two things. Okay? One, that this is a solid line. So when I graph this, it's a solid line. And the second is that I'm going to use the inequality when I am going to test a point, right? And that's going to help me shade. Okay? And what do I mean by shading? Because with inequalities, we have multiple answers, not just one, right? So like an equation, we don't have one answer or two answers, but specific, right? Where with inequalities, we have a whole slew of them. So if you think about how many numbers are less than 5 or equal to 5, we have a lot of them, all right? So now that we're going two dimension, it's even more. All right, so let's say that I have x is less than or equal to 5. So the biggest part is that I'm going to have a graph here. Definitely wanted that to be black. Let's draw another one. There we go. Okay. So x is less than or equal to 5. So if this is 1, and this is 1, so this is -1, and this is -1, okay? So that means each block is 1. So x equals, so the way I would look at this now, from this point forward, let me do this. Move this whole thing down a little bit. Okay. Now what I'm going to do is that I'm going to take the original equation and let's use green. Okay, so now I'm going to pretend that this is now x equals to 5. That's what I'm going to graph. If x is equal to 5, that's a vertical line, okay? And I want it to be solid. So the line is 1, 2, 3, 4, 5. So here's my x equals 5 line, and it is solid. So there it is. So this right here is my x equals 5 line, right? Now, so part one, check, done, okay? I graphed a solid line at x equals 5. Now I need to test a point. Now with vertical or horizontal lines, you don't really need to test because it's pretty obvious what is less than 5. So everything to the left of 5 would be less than, because the 4 is less than 5, 3 is less than 5, right? 2 is, 1 is, 0 is, and so on. So what we would do is then shade to the left. So then this right here would be my so-called solution, okay? So everything to the left here, any of those points to the left of that line is going to be part of this solution. So this right here would be my answer, all right? Now similarly, if I was to say, let's say for example, on the other end of things, let's say I'm gonna graph x is greater than 5, okay? Again, I look at the inequality, and that's going to give me two things. One is that this is a dotted line, and 2 is for test being a point for shading. Okay, so let's do the same thing here. X is greater than 5. Okay, so let's actually do this here. Make this shorter. There we go. All right, so let's take this equation here and let's make it blue. Actually, let's make it light blue, okay? So now I'm gonna take this equation here. I'm still going to graph the equation x equals 5. However, this is gonna be dotted, all right? So while I'm doing the notes, I have to do it this way, so please be patient. 1, 2, 3, 4, 5. Notice it's not dotted. I understand that. So now I'll make it dotted. There we go. Okay. So now it's a dotted line, but I want it to be greater than 5. So now it means that everything is going to be shaded to the right, because 6 is greater than 5, 7 is, 8 is, and so on and so forth. So any point in that shaded region would be considered part of my solution. Okay? So that's what you would do, right? So this is something that we did a while ago. So let's go into something a little more challenging. For example, let's say I had to graph x squared plus y squared is greater than or equal to 4. Well, what I recognize is that this is a circle, okay? So when I look at this part right here, when I look at this part right here, it tells me two things. One is that it is a solid line, right? And that the second is going to be test a point, and that's all for throwing shade towards, right? Okay, so now I'm just going to deal with this as if it was a regular equation. So x squared plus y squared equals 4. What do I know about x squared plus y squared equals 4? Well, I know that the center is 0, 0, and my radius is 2, okay? All right, so let's go ahead and draw some lines here. Okay, so my center is 0, 0. And my radius is 2. So it's going to be here, 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 and here. So let's see if I can make a radius of 2 here. Yeah, look at that. Not too shabby, Jimmy. All right, so there's my circle with a radius of 2. And it is solid, right? Because you told me it's solid. So that part is check. So what do I mean by testing a point? So what I want to do is now test a point either somewhere on the inside or somewhere on the outside. Doesn't really matter where, okay? Just as long as the shading is either going to be inside or it's going to be on the outside. So I am either going to be shading here or shading out here, okay? The question is which one, all right? So that's why we need to test a point. One of the points that's easiest to test if it was available, meaning no line is going through it, would be the origin, 0, 0. That'd be the easiest one to do. So that's available because it's not part of the circle, like in terms of the line aspect of it. So we can use 0, 0. So then we got to bring that back to the inequality. So testing, I'm going to put down 2, testing. So it's going to be squared plus blank squared. Is that greater than or equal to 4? Okay, so it's 0 squared plus 0 squared greater than or equal to 4. So in other words, is 0 greater than or equal to 4? And the answer is no. Okay? So if it's no, that means the shading is going to be on the outside. Since 0, 0 is on the inside, and that's not it, that means the right answers must be on the outside. So now it's shade on the outside. Let's go ahead and do it this way. Okay, there we go. All right, so that would be my solution. So anything that is in green would be my so-called solution. All right. The next thing I want to do is if it was system. So this right here was something pretty simple, and then this is if it was one inequality. Now we're talking about what are the systems of equalities, right? So in other words, what we were given 2 things. So let's take a look. Let's say I got y is greater than x squared minus 3. And I have 3x plus y is less than or equal to 6. Okay? So let's go ahead and I'm going to make this right here red. And I'm going to make this right here blue. Okay? So we kind of have a discrepancy. And hopefully this keeps on recording. All right. All right. So that's what I lost. Okay. Blue. Okay. So now, if I was to look at it, I'm looking at this right here. This tells me that this is going to be dotted. And this right here tells me, oops. This right here is going to tell me that it is solid. Okay? Awesome. Great. All right, so let's graph them one at a time. So let's look at the red equation. What do I know about the red equation? In fact, let's even do it one better. Let's take this and just move it right over here, okay? So that we see exactly what we're trying to see. And let's work with the red equations here. So in the red equation, that's a parabola. So what do I know? All right, so I know there's a parabola or a quadratic, right? I know about the f of x is equal to a times x minus h squared plus k, right? Okay. So I know that this is going to be a smiley face because a is 1, right? So if I was to kind of connect the same thing, I'll have y equals 1 x minus 0 squared minus 3. So if you look at that, what do I know? I know that my vertex is 0, negative 3. All right. And then I can find, from there, I can do two things, right? One is I could either plug in, make a table, plug in a couple of numbers above it, plug in a couple of numbers below it, or I can find my x and y intercepts. I know I can find my y-intercept. Never mind, it is the vertex, so that's good enough. So let's go ahead and make a table. So if I made a table, so here's my x, here's my y, and I know my vertex is a 0 through negative 3, so I'm going to put 0 right in the center, and that's going to be negative 3. 2 above it, 2 below it, right? So above it would be 1 and 2, below would be negative 1 and negative 2, okay? So if I put a 1 in the equation, what would I get, right? Because remember what I said before, I'm going to make this just a regular equation once I get the fact that it's dotted. So the regular equation would say y is equal to x squared minus 3. So if I plug 1 in there, 1 squared is 1, minus 3 is negative 2. Put 2 in there, 2 squared is 4, 4 minus 3 is 1. Negative 1 squared is 1 minus 3 is negative 2. Negative 2 squared is 4 minus 3 is positive 1. Okay, so great. I have my how to start on this side. And then over here, I can solve for y. So I can say, okay, 3x plus y is equal to 6. So y is equal to negative 3x plus 6. So I know that my y-intercept is 0, 6, and my slope is equal to negative 3 over 1. All right, so let's go ahead and graph this. Okay, there we go. And I'm going to make a table here as if this was a 2 and a negative 2, 2, and a negative 2. Okay? All right, so let's do the parabola. So I have 0, negative 3. I have negative 1, negative 2. Positive 1, negative 2. And I have a 2, 1. And a negative 2, 1. So there it is. I probably should go out further. Let me see here. If I went 3, let's see what negative 3 gives me. Negative 3 squared is 9. 9 minus 3 will be 6. Okay. So let's go ahead and do this. And it was 4, it'll be 13. So 2, 4, 6, 8, 10, 12, 14. Okay. So this is dotted. So let's go ahead and go dotted. Boom. All right, so there's my parabola. Now, we can also test this too to see which way it is shading. So let's take a look. All right, let's test. Let me see here. 0, 0 is available. So let's test 0, 0. All right, so let's test 0, 0. So the question is 0 greater than 0 squared minus 3, right? So we gotta use the original. And is this true? Is 0 greater than negative 3? And the answer is yes. So that means for my shading here, it's actually gonna look something like this. Is everything that goes with 0, 0. Okay, so everything inside is going to work. Now let's go with the blue now. Okay, so that has a y-intercept of 0, 6, 2, 4, 6, and it's a slope of negative 3. So down 3, 1, 2, 3, right 1. 1, 2, 3, right 1. All right, and that is going to be a solid line. Perfect. So let's see how this is shading, right? So 0, 0 is also available, right? Because it's not, the blue line is not touching that. So let's test 0, 0 as well. So let's go try and find a place to test it. Let's just test it right here around the side. So we want to test 0, 0, okay? Is 3 times 0 plus 0 less than or equal to 6. So 3 times 0 is 0 plus 0 is 0. So is 0 less than or equal to 6? And the answer is yes. Okay. So that means I would shade towards 0, 0. So this shading will go in this direction. Now, obviously we have 3 different types of shading here, right? We have the blue only, we have the pink only, and then I'm not sure what this color is. It looks like some kind of bluish, purplish color, okay? That is a third. Now, wherever it is doubled shaded would be your solution. So what you would want to do is to kind of do this right here. Undo. Of course. Okay. It's much harder to do. Yeah. I think you guys get the gist of this. Okay. And you can't forget this side either. Oh, shoot. That's a little ugly, but that's where you really have it. Where it's double shaded will be your so-called solution. Ooh, that doesn't come out very well. Let's just use this, and let's use a thick version of that and call this your solution. Okay? So this is what you will have. All right, so wherever it's double shaded is where your solution would be. So any point in this sliver would work for both inequalities, will satisfy both. So if you use, let's say 0, 2, 0 for x, 2 for y, in both of these inequalities, you'll get a true statement for both of those. All right, hopefully it helps. If there's any questions, let me know. See ya.